the cos of 2a is 1 plus cos squared minus sine squared. I do not need anything fraction line there now or anything. Now where am I going here? Ooh. Well, 1 minus sine squared, if I take this and this, that is equal to cos squared. So that's 2 sine cos. Okay, so that's equal to cos and that's equal to cos. So that's 2 cos squared. So you can cancel a cos with one of those cos's, and you can cancel the 2's, and you're left with sine over cos. Okay. This is reminding me a little bit now, as I look at this, of the difference of two squares in some manner, but we'll see what happens. So tan of 2 theta is equal to 2t over 1 minus t squared. Checking my log tables there, just making sure. Okay, so the question is, and here's the difference of two squares, because I can call that a square. And the question is, will that turn out to be, there's my line, will that turn out, am I looking on the screen? Here I am. Will that turn out to be 1 minus t minus 1 over 1 plus t? Well, let's move this along now, will we? So let's multiply this here by 1 plus t over 1 plus t, because that'll give me my difference of two squares at the bottom, and they match. Now I have to be careful though, because you have to be careful about cancelling. Anyway, I'll continue what I started there, and I'll go 1 minus t times 1 minus t, and that's 1 plus t minus 1 minus t. That's the top, and the bottom is now simply 1 minus t squared. Now I haven't crossed over yet, I haven't said anything left and right, so I simplify up the top here, and it's 1 take 1 is grand, and then minus minus t is t. So that's equal to 2t over 1 minus t squared is equivalent to 2t over 1 minus t squared. Okay, so I've shown the left equals the right. Well, that's a double angle in disguise. So this is a double angle, the sine of double 2a. So let's apply the identity for sine of a double angle, which is double the sine of the individual angle times the cos of the individual angle. Well, if I look in here, there's a cos of 2a, but there isn't a sine of 2a. Because the sine of 2a has just decided to replace it. So if I replace the sine of 2a, I will get, so I'll leave him alone, I'm only replacing the sine of 2a now, but the sine of 2a is double sine a cos a. Okay. And that cos 2a stays there, because he's here already and he's here already. Okay, well that's equal to 4 sine a cos a and cos double a. And they're equivalent. Should we be looking back, is this the kind of thing you need every day? Don't know. But certainly we'll always try and make it, be aware, because there's only so many of these things can come up in exams. So just be aware. And these kind of identities are on, so this kind of thing is not by any means not on the course. Which begs the question, by the way, why wouldn't the rest of the 24 equations be on as proofs? And I would just say how formal they would need to be. I would still think that they could be asked maybe in some informal way, because they're less rigorous about proving things like this. I think they are anyway. So that's done. And so 4, it's as if the 4 jumps out. It's as if you had 4a, now you have a and 2a. Now I'm being totally silly, okay, but I'm just giving myself a chance of trying to remember it. So sine of 4a equals, and I'm going, oh, what was that formula again today? The 4 could jump out. I had 4 angles, so I'm going to have it an angle, and a double angle. And it's going to be sine, cos, and then cos of 2a. So it might be, it might have stuck at this stage. It might not. One way or the other, it'll be no big deal, but I have the right spirit. Okay. So I don't really know where to go with this. I would say that that's cos squared minus sine squared. And this is the difference of two squares. Okay. Let's kick off here for a second. What's the cos of 2a? The cos of 2a is cos squared minus sine squared. What's wrong here? Cos of 2a is cos squared minus sine squared. I nearly need to look at the book. I'd say that they're asking me to solve this rather than to show that it's an identity. And we'll come back to that later. It doesn't seem to make sense to me. Cos squared. Oh, it does make sense. Sneaky. Okay, so cos squared, it is cos squared minus sine squared, but we could just drop in cos squared minus sine squared. We could drop in a trigonometric one, a cos squared plus sine squared, which is just 1. For luck, why not? Okay. And that's the difference of two squares, and if this is the difference of two squares, it's the square of that minus the square of that, which is cos to the 4 minus sine to the 4. You gotta love it. That was a super question. Okay, and then a question to ask you and for you to investigate: does that cascading continue? Can you keep doing that? And can you say, well, that's the same as cos to the 6 minus sine to the 6? Or I don't think so, but I think you can go to cos to the 8 minus sine to the 8, because maybe not. Interesting question. We go with that. I think I can see the answer is no, but that's for you. On to 13. Oh, it's tiring. Okay, question 13. The tan of blah, 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 blah. Okay, so I don't like anything going on here. I don't really know how to think about it right now. But I do like this, because I know that I can just jump in here. Well, that's tan of double angle. There's only one way to deal with tan of double angle. It's to call it 2t over 1 minus t squared. Holy cow. Which of them is darker? You'll have to let me know. Is that much darker? It is. 2t over 1 minus t squared. Any other way to go with this? Yeah, we could use the tan of a plus b and then the tan of a minus b, and I think that's maybe the way we should go. So let's go with the tan of a plus b. So the tan of a plus b has a plus on the top, and it becomes the tan of 45 degrees, which is just 1, plus the tan of a, which is just t, all over 1 minus, now they can ignore the tan of 45 because it's 1, all over 1 minus t. So that's equal to that using the formula tan a plus b is equal to tan a plus tan b over 1 minus tan a tan b. Okay, that's that formula there. Okay, on the left hand side, and then we're using the formula on the right hand side. And what's happening is with one of the angles it's 45 degrees, so it's the tans are turning into 1s. So this becomes 1 minus t over 1 plus t. Okay. And then this becomes, we just use the tan 2a formula, which is 2t over 1 minus t squared. And we've been here before in a different guise. This question came up just a while ago. Okay, so technically speaking, it's that by that, which is t squared plus 2t plus 1, okay, minus that by that, t squared minus 2t plus 1, there's going to be a lot of cancellations there, all over that by that, which is 1 minus t squared because of the difference of two squares. So if I pre-cancel before the distribution, I'm getting 4t. Wow, why am I getting 4t? Oh, there was a 2 out here, so that becomes, and that's okay, I can pick that up now at this stage. And I'm getting 4t over 1 minus t squared, and it's true. Okay, is there any end to this? Okay, here we go. So we're thinking about this and we're wondering, or should we pop him into, let's turn him into sine. Now you have different options here, but let's turn him into sine over cosine. And let's just get busy with double angles here. So let's replace this with cos squared minus sine squared, so it's going to turn into minus cos squared plus sine squared. So I've pre-distributed the negative into the fraction. Sine of 2a is plus 2 sine a cos a. Down we go. Nothing special happening there yet. And remember, I'm not allowed to divide across, so there's going to be some tricky stuff coming up here. This becomes 1 plus the cos of 2a. Cos of 2a is cos squared minus sine squared, plus cos squared minus sine squared. Sine of 2a is the same as he was before. Now you've got to be careful here. You cannot say, I'll do, not that you can anyway, but you've got to keep this line separate. Okay, do not do dividing across or anything. But hey, come on. 1 minus cos squared is sine squared. One minus cos squared is sine squared. I don't know if it's that much good to me, but I get 2 sine squared plus 2 sine cos. Just a little point here. Sometimes people would just go and say that's 2s squared plus 2sc, and 1 minus sine squared, 1 minus cos squared is sine squared, and 1 minus sine squared is cos squared. So you get 2c squared, as in 2 cos squared, plus 2sc. Okay. So we're going to take out an s on top. And take out a c at the bottom. Take out 2 actually. Take out 2c. You get c plus s. They cancel. I'm allowed to do that. And they cancel. You get s over c equals s over c. You rest your case. Okay. Write the tan of 2a in terms of the tan of a, hence or otherwise. Which we know the tan of 2a is 2t over 1 minus t squared. Okay, so hence or otherwise find the tan of a. Oh, so if tan of 2a is equal to 3/4, so you call this 3/4 and you solve. So it's just algebra then. 8t equals 3 minus 3t squared, 3t squared plus 8t minus 3. 3 3s is 9, take away 1 is 8. So this is a sitting duck, this is a cinch. 3t and t and 3 and 1. Okay, that has to be positive, that has to be negative. Now we could be careful now to not use a calculator, hence find the tan of a, but it's an acute angle. Acute angle means we need a positive solution. Whoa, and we do not want, well, I'm in trouble. 8, 3t minus 3t squared. Okay, it's correct up to here. Oh, yeah, 45 degrees is the answer. So t minus 1 implies, that's a factor, implies t equals 1. I was getting confused with, you know the way sine and cos top off at 1, but tan equals 1 is only 45 degrees. Okay, so tan of A equals 1. Inverse tan. The principal value for inverse tan of 1 is 45 degrees. Do not use a calculator, blah, blah, blah. And be careful, I'm giving the answer. Find the tan of A. So the tan of A, the answer is 1. Because they didn't ask for the angle, they asked for the tan of it. So question 16, write down cos of 2A in terms of tan of A. So cos, that's the odd one out. That's the one that goes 1 minus t squared over 1 plus t squared. Double checking. Again, always try and do it and then check, rather than the other way around. If you check, if you look it up, you're learning nothing. Cos of 2t equals this. Hence or otherwise, find the one that has that equals 5/13. So pure algebra now, into the algebra world we go, and we get 13 for cross multiplying up that way. Take 13t squared equals 5 plus 5t squared. Oh, this is pretty. Okay, so that's 18t squared equals 13, take 5, 8. 4 equals 9t squared. T squared t, because we're looking, we know we can go with the positive version, equals 2/3. Find the tan of A. Tan of A equals 2/3. Okay. And we're on to question 17. Now,